the link to this presentation that's on your screen right now, I tried to put a short link down there at the bottom right of each screen. So as we go through different things, if you don't know where we are, how we got to the presentation, there's the link. My goal with these sessions is just to help people feel more comfortable with Fusion. I know a lot of us here tonight, we're like 81, 82% educators that signed up. There are a few hobbyists and there are a few engineers as well out there that signed up to take the training tonight as well. Our big goal is we want the best experience we can for our kids. Along with us tonight, we have Craig. Some of you know Craig. He's a rock star on the videos.
Sure thing. Just yeah, got a lot of resources out there. Been adding some stuff, just like what Brian's trying to do tonight. Just hopefully helping all of you out, or just whoever's willing to look at it. To be able to hopefully help them out with anything they're wanting to do, either in the classroom or hobby wise, or just for the sake of learning whatever software. Usually, it's always Project Lead the Way related, so it's kind of what I do.
Our other rock star tonight is Mr. Williams here. Austin.
Nothing new or different really from Brian or Craig what they do. I'm a little bit fresher to the game than those two guys are. But overall, my big project that I've been working on is the 100 Days of Fusion, 100 Days of Onshape. So I haven't delved so much in the realm of what those guys do. However, Onshape is kind of a secondary master as well. So if you are also looking into that and you have questions on that, feel free to reach out to me. If you're looking for more of the robotics, Brian's your man. And if it's like Revit or some other specialties, Craig can be your guy as well. But yeah, same guy. I'm just here to help out some things and see whatever people need. And I'll be sticking in the background, probably most paying attention to the chat, unless I'm needed for something particular.
I did put this link in here. This was our webinar from the last time. So for those of you out there that are watching the recording of this or that are here live and didn't get round one, there's a direct link to it from YouTube. And then also, here's kind of our agenda for tonight. We're going to go right into assemblies, and then we're going to do some rendering. We're going to do a couple simulations. I'm going to try to do, I know we're going to do at least one simulation. I'm hoping that we can do two, though. And then we'll send you on your way with a nice little parting gift. I did want to continue to throw this out. This is a course I put together for Autodesk, how to learn Fusion. Learn Fusion in 90 minutes. And as I went through it, I geared it not just for teachers, but also for students so they could follow along. It's video based, and there are some labs in it as well. If we don't cover something tonight, there is a high probability that it's in that lesson, and that's a free resource out there. We've also started a Facebook group called the Stream Team. It's pretty interesting. We started that just to share ideas. I know a lot of you came from the Project Lead the Way teacher lounge and the modification lounge. This group, I guess the real big difference between this group and those is that we have added, construction and transportation and manufacturing and agriculture and basically any technological related field here. So it's not necessarily Project Lead the Way specific, although I'm sure you're going to see a lot of that as you go through those. So please feel free to join. There's the link. And honestly, if you click the picture, it'll take you straight there as well. Let's get into assemblies. When I talk with the kids, the first thing I tell them is like, all right, when we put multiple things together, we need to figure out how these things are going to move together, how they're going to interact together, kind of motion we're going to get together, maybe even what is kind of the central point of this assembly. So I usually compare it to the body and like, your torso. That's going to be the grounded component because that is what everything's attached to. And then I say, all right, let's look at our arm. So if we created a fusion assembly and we've got our torso and we're going to add our arm, what kind of motion are we going to get in our arm? I'll ask them, I'll be like, so let's start at the shoulder. What kind of motions at the shoulder? And I'll demo in front of class. I'll just kind of move my arm around, and they're like, well, that would be like a kind of like a ball and socket joint. Good. All right, so what kind of motion do we have at our elbow? And they'll come up and they'll say something like a hinge joint, and then you'll talk about the wrist. And so you're kind of just putting it in context for them and just saying, all right, what kind of motions are we going to have to deal with? Because those are the big pieces of it. So I did put a video in here for you. If you want to use it, fine. If not, that's fine too. But it just goes through the fusion joint types. I think I go through there and show them what each one does. This is what we're going to start with. This is called the quick slider. Craig and I, we use this a lot. The reason I did this in class is because I did this as a team project. So this was really the first time that our kids got a chance to use Fusion teams. So they would be on a team of 4 to 5 people, and sometimes 3 to 5 people, and each one of them had to create a certain component in this, and then they had to put them all together. So you can see if you click the picture here on the left, that will take you and you can download this file and then you can upload it to Fusion. Over here on the right where you see the assembly drawing here, the exploded view, if you click that, it will give you the PDF of all the dimensions. On the following slides, actually, you're going to see the dimensions of each piece. So this is a really simple assembly to put together, and I feel like everyone can contribute something to this. Like that part, not difficult. That part is probably more difficult at the point of the year I give it to them. And maybe this part here could be a little more difficult. So there's a range of abilities in each group, as we all know. So what my plan is I'm going to take you through these actually just using Fusion. If you want to follow along, I'm going to create each part. The first thing I'm going to do is I'm going to start with a new component. All right, so we'll start with a new component, and I'm going to call this one the base piece. This is going to be that bottom. Well, it's going to be this green piece right here. So this is the base piece. Right, so there's my numbers, 2 by 5, and it's 3/4 stick. So base piece, click OK, and you notice it puts it over here. Good habit, though. Before I get going too rambunctious here, I should probably go ahead and save this thing. So I'm going to save it, and I'm just going to call it Quick Slider 2. It's good practice to save things as you get going. All right, so I've got this component. I'll start with a new sketch here and get down here on the bottom. I'm just going to go with a rectangle here. The rectangle is supposed to be 2 inches tall by 5 inches long, like that. And then I'll go into extrude. So I can either finish sketch here, or just press E for extrude. And this is supposed to be 0.75 thick. All right, so I've got my base piece. I'm going to go back up here to the entire assembly, the quick slider assembly, and I'm going to click on that little radio button right there, right here. So I'll click on that. That'll activate the whole assembly. And I'm going to say new component again. This time I'm going to use and do the end pieces. Okay, so to put some context on it, we are looking at this piece now. So I've got my piece. I'm going to go to new sketch. And I'm actually going to use the piece that's already here. And I'll just draw a square coming down. And I know that this is supposed to be 0.75 thick. So now I'm going to extrude this thing. Because see the other dimensions, because I used the extents here, I didn't really have to dimension those. So I'm here. I'm going to extrude this piece up. And let's just make it like, let's do 3. That feels better. All right, so there's that. I'm going to put that hole in there now. There's a couple ways to do that. At the beginning of the year, the kids are probably just going to put a circle in. But here's the hole command, which is actually a whole lot easier. put it there. Remember, in our first night, we learned how to use the navigation and all that stuff. So hopefully your kids are good at that by now. But what I'm going to do is just kind of square that up. I'll choose my reference and I'll say from this edge should be 1 because it's half of 2. Then I'll go at another reference and I'll say, all right, from the top, let's make that, let's make it like 0.75. The diameter there, let's make 0.5. Like something like that. Okay. And finally, what I'll do is I'll just use a fillet up here on the modify tab. So there's fillet. I'm going to click both edges. I think I'll just make the radius 1. And that'll play pretty nicely. Now, just a quick shortcut. I press the A key and that will pull up the appearance box. Pull up A. That'll pull up all the different appearances that are available. Okay. Likewise, though, you could, instead of going there, you could right click on the piece and you could say appearance. You could also do physical material and actually set physical properties. But for now, when we're in assemblies, I always try to encourage our kids to use different colors. I think it helps them a bit. So for appearance, I'm just going to go down to the paint section, choose the glossies, and I guess this one will make it red. So next step, I'm going to activate. So quick slider, I'm going to activate the whole assembly again. So now my pieces are back, right? As we build these things, if you'll notice, this thing can move, right? It wasn't like that when I originally started it. I was using that piece. So I'm going to undo that little movement I made. I'm going to show you a quick little trick here. Rather than waiting until the end to assemble everything, I can actually go up here to assemble. Right in here to assemble. And then I'm going to click as built joint. So as built joint. And what I'll do is I'm going to select that piece and the base piece. And for motion, for this, it's going to be rigid. I don't want those two pieces to move. And I'll press OK. So now this whole thing's going to move together. So those are essentially already jointed, or for those of you that are in Inventor World, they're constrained. Before I get going too crazy, I want to ground something. Remember, I need that torso, right? So this might be an arm, this red piece, but I need the torso to be grounded. So base piece, I'll right click on it. Right click on it, and then I just choose ground. And you'll notice I'll click capture position. This really has more to do with rendering, which we're going to talk about in just a minute. But you'll notice there's a little push pin there now, and that lets you know that it's grounded. Now, rather than draw another one of these, I'm going to right click over here on end piece. I'm going to say copy. And I'm going to right click again out here and just say paste. So it didn't look like it did anything, but it's there because there's the arrows. Now I can just drag the arrows. And I want to line that up. Didn't quite play really nice, but if I go too far, so I'll type in 4.25 right there. Now it's lined up really nice. Now the issue here, this I can pull and drag. See, that's not supposed to happen. So I'm going to undo that real quick. And I'll go up here to assemble. And I'll say as built joint again. As built, and I'll click the end piece and the base. And rigid is perfect, so I'll click OK. So now this thing is in great shape. It's fully jointed together. I need to put that rod in there. So if I look at our actual drawings here for the rod, it gives us full dimensions. It says it's supposed to be a 0.5 diameter and 5 inches long, but I've got enough here. I can actually just use this. So I'm going to make sure the entire assembly is active, which it is, because there's that little dot, right? And I'll choose new component, and I'm just going to say maybe handle, and then I'll say new sketch, and I'll click on the end. I'm going to use the geometry I already have. I already have this circle here. I'll just choose circle. And actually, you know what? I could draw a circle here if I want. Or since the circle is actually already there, I can go ahead and press E and just click that circle and extrude the thing. Drag it on back. I do happen to know that that's 5 inches. So I'll just press enter. And there's my handle. Right there, I'll activate the entire assembly again. Okay, so the problem though is watch this. That's not supposed to happen. Right? So I'll do again. I'll say assemble and I'll do as built joint. Like any of the end pieces, like that, and then the rod itself, and press OK. Now all of that's going to stay together like it's supposed to. So finally, we move into the last piece of this thing, and that's actually the slider block itself. So it ends up being about a 1 inch square or 1 inch cube with a 1/2 inch hole through the middle. So I've got the whole thing active. So I'll say new component. And this I'm just going to call the slider block itself. Slider block. I'll start another new sketch. I'll go ahead and click on this end piece. And you know what? I've still got that circle. That thing is my friend. And I'll use a center rectangle. So I can go to create. There's rectangle. And there's center rectangle. You notice that Z there. I've actually set that up to be a hotkey for me. If you click these three dots, you can say change keyboard shortcut. And then you can set up your own hotkeys, which is kind of nice because like if you press C, you can get a circle. If you press L, you can get a line. This center rectangle I use frequently, so I ended up just making it a hotkey. I went over there to the center of the circle and I'm going to say 1 by 1. And then I'll extrude the thing. And it also needs to be 1. Just to be organized, I'll go to appearance and I'll just drag that and make it yellow. Close it. So I'm going to activate the entire assembly again. So there it is. Now this thing's moving, which is okay because we need to constrain or we need to joint that a little bit differently. And we've done all these other ones. We could have done an as-built joint, but I think for this one, it's probably going to be easier just to go to assemble, say joint. And what I'm looking at doing is I want to kind of get that center. So I click that, and then I click the center of the axle. And so you can see my last movement was a cylindrical joint. Probably that's just going to be rigid for you. So I do need it to be cylindrical though. So I'm going to make it go over to cylindrical. So you can see the movement you're going to get. And that's good, but I'm going to turn it to the front view here. And that thing is just all kinds of not where it's supposed to be. Actually, see how that's on rotate? I need it to be on the slider. I can care. It's okay if it rotates, but on the slider part, that's not so good. I don't want it going through it doesn't need to defy the laws of physics. We'll put it that way. So I'm going to drag these arrows here. I'm going to move this over here to where it can slide all the way without going through things. And then I'll use my other over here to set the maximum. Okay, so now if I press the play button, you can see it goes back and forth and it doesn't go through the wall. Now, if I actually just click that yellow gold piece and drag it and move it, works just fine. It works like it's supposed to. So we're actually going to take the very slider that we just created here. We're going to take this slider and we're going to render it now. Some free advice though, clean it up a little bit. So like the joints, how they're showing up, that's awesome and everything, but I don't need that to show up in the render environment. So what I'm going to do over here is I'm going to kind of go right here to this eyeball and I'm just going to uncheck it. So I'll turn that off and you notice over here, they went off the screen now. So I'll toggle that so you can see it. There they are on, now they're off. Likewise, if you have other pieces, I'll give you I was doing this while I was kind of preparing for you all. Here's a quick slider version I made. This one actually has a table below it. Okay, so I actually created this table for it as well. So if I don't want that table, if I don't want to deal with that in my render, what I'm going to do is just turn the table off. Okay, so that way I only have that. So that can help right there quite a bit with your kids just to simplify things. Okay, let's go back to what we actually created. So we've got this. To get to render, I'm going to go up here to design. I'm going to move right here to render. Right there. Before I get moving too crazy, though, I'm going to go ahead and close this data panel so we can get a little more space on the screen. So I'm just going to close right here. Now we've just got that. So I'll go to design and I'll say, hey, let's go to render. Go to render. Might take a second or two to pop that up. But you notice immediately the thing with rendering is we get into where we were talking at the very beginning of the year with them about shading. You know, if we did the lighting differently, it looks more realistic, right? So I kind of work left to right. So I'm going to go right here to the appearance wheel. I'm going to click right there. And so now this to me is not really natural. So I'm going to go down and move into like wood, solid wood. Now I've already downloaded just a ton of these. But for those of you that are looking through these appearances, and again, to get here, there's the appearance wheel. And I can go through here and there's just a ton of stuff. For those of you that are kind of new though, you see the little download icon here? You have to download those. They don't just come standard with Fusion. You have them available, but you have to download them if you're going to use them. It doesn't even take half a second. So maybe I want to use this cherry here. I'm going to just drag it over and put it on my red piece. Because that red piece was a copy and paste, right? It's going to apply it to both. And then I think for the bottom, let's just go goofy here. Let's do like a really glossy, let's do the maple glossy. And all I'm doing is I just drag it over. So if you're out there and you're trying to drag it over and you're like, man, it's not dragging, make sure that you don't have to download it first, okay? All right, so for the bar here, I think I'm going to skip up to metals maybe. And let's try like let's try chrome. Chrome and then there's black chrome. I'm just going to drag regular chrome over. Not much of a difference, but a little bit. And then on the block itself, let's see here. Wonder what I could do with that. Maybe another wood there. There's solid woods that are finished. There are other kinds of wood as well. These are more standardized here. I'll make it. I like working with pine. I'm sorry, but I do. So I'll drag it over and it's a pine piece. Okay. So I'm just going to do close. All right. So there is, I've got some new appearances, and some of you are like, well, big whoop. I could have done that in the actual part. Well, here's where things get a little different. So I did appearance. Now I can go to scene settings. I'll click here. This is where the stuff gets fun. So I can see, brightness. Let's change that brightness level a little bit. And then maybe for the color background, right now I've got it set on solid color. I can actually change that to environment, which we'll get to in just a second. But I can maybe say instead of that gray background, you know what? Give me like a bluish. But I could do reflections. Oh, I gotta get out of here first. Try to do reflections and see how it kind of puts that mirror finish. I can change the roughness on the reflection, make it crystal clear. The flattened ground's not gonna do too much here, but as soon as we get into environments, that can make a heck of a difference. On camera, there's the orthographic view, which is pretty standard. That's front, top, right side stuff. And then you got your exposure. which turns to me into more of like a brightness thing. But I like doing this perspective and perspective with ortho faces because the focal length changes and I can kind of skew it and stretch it and I can change the exposure still. And let's talk about the environment stuff. So to turn on any environment libraries, to turn this on, I don't know if you caught that. I clicked, there's two tabs up here. To get here, you can get there anytime you want, but in settings, you have to change the background. Right now, it's solid color. I need to actually change that to environment. Okay, so now that it's actually changed to environment, I can come back up here to environment library and I can try some of this stuff. So maybe I want to put it put it in the middle of a field. So I've got the field, I'm just going to drag it over. Got to give this a second here. But there it is. And then I can zoom out and I can see this thing in a more realistic environment. Of course, I don't know that I'm ever going to have this in the middle of a field. So maybe I'll play around and put it like in the plaza. Let's see that. I'm just gonna, again, I'm just dragging it over and there it is smack dab in the middle of the plaza. Okay. Now, if you notice down here, I can just play, it's not just necessarily a scene like that. You rotate that though so you can see. So there's different backgrounds and stuff. But this is not very realistic either. So I can actually go to a custom environment here and I can download environments that are out there on the internet. In the presentation, I left you a couple links here. So on this slide here, this is slide 19. There's the Polyhaven and HDRI Haven. You can actually go out there and down. Here's some actual renders I did. So here's that same piece on a table. Here's the same piece on a desk. And I found this is like a ballroom scene I found. And you can see that white piano, but there it is again. Okay, so right there is my render. I just set it right there on top of that table. The kids, they really have a good time with this stuff. It's really artistic in nature. Let's get back in here to Fusion. So I can show you how to attach a custom environment. After you download it, you click here and it'll pull up your computer and you can say, select from my computer. Okay, so I go there. I think I have a few in the downloads. Here's some that I've previously downloaded. Actually, you know what? Let's do this workshop. I can't remember which one's which. So I'll upload it because all I did was select it and now it's uploading it and it's saying, all right, there's your workshop, buddy. Okay, so I'm going to go back into settings now. And for focal length, I might change that a little bit now. And then I can use the pan tool. I can kind of place this in different spots. So if you play around with it long enough, you can even go up here on position and say move. And you can make it raise up a little bit and then you can rotate the scene and I can eventually get it to where I can move it over to this table and actually make it, in a realistic environment, which I think that's what the kids get onto more than anything is they're like, hey man, I really want to check that out. Now you notice the background just looks all weird, but if you look right here, I have this flattened ground thing checked. That's why it looks so funky. So let me uncheck that. Oh, look at that. It got realistic in a hurry, didn't it? So now I can kind of zoom in here and I'm like, all right, that's up in the air, suspended animation. I'm going to drop it down here a little bit. And I think I'll play around with the reflection here, maybe. Maybe take that off and I can go to focal length and kind of put it closer to something. I can go back up to brightness. I can change all kinds of settings. The big key here is to tell your kids, hey, you need to play with this because there's some really cool stuff you can do with it. Right? So those are the big things with render is just setting it up how you want it to look. So the big things for me were, there's my appearance. So I added some wood to it and a little bit of lighting as well. And then I set a scene for it. I think the big key there is when you get to that environment library, to find you some custom environments. There's a lot that is available to you already. Let's go back to the Fusion library. Like maybe I don't want to put it in any environment. I just want to change the lighting around. So here's a soft light environment. I think is kind of boring, but hey, if it gives us a pretty clear picture of it, that's awesome. Is what we're trying to do with our kids here is we're trying, and I keep saying kids, and I realize some of you watching this are not teachers, but what we're trying to do is put this thing in a realistic environment so that we can communicate our design to others, right? That's the huge piece of rendering. That's what we're doing. So I'll go ahead and close that. Now, what you're seeing here is somewhat of a render. It's a very good preview of a render, but if we go next door, you can actually throw decals on stuff. That is really cool. Like, I know Corey, I want to say he did like a soda can one time. It was really cool. And I know he has a fishing lure thing that he does with the decals. It's really cool. So the texture map controls, you can actually come in here and you can say, all right, let's take this piece and let's try different textures with it. You can make it rougher, all kinds of different things that you can do with that thing. It's pretty neat. And then when you get things done, you get things the way you want them. There's an in canvas render, and then there's just a regular old render. If I do in canvas render, and I'll go ahead and click on it, it's trying to take care of that right now. And you can see it takes some resources from your computer, but you can see that the render its whole purpose is to make this product look more realistic. Okay, so in-canvas render can be really taxing on your computer. I got to go back to the scene. I can't stand it not having like a real environment. So I'm going to put our workshop back up there. Put that in and make it look more real again. There we go. And then I'll use my pan tool. That's so much better. It's more realistic than just sitting in air. So in canvas render, that's neat, but most people go over here to render. They'll click it. And the beauty of this is it is taxing on your computer, but you can also do a cloud render. So you can use basically Autodesk's resources and they can render it in the cloud. I tend to like where I'm at right now, this computer I'm on is kind of it's a beast. So I can just do a local render and it's pretty quick for me. But a cloud render is what I use in the classroom when I get to do this, because rendering can take a considerable amount of time. You can see down here it says render queue is 10 minutes. For those of you that are teachers, you know 10 minutes is an eternity. Okay. And we often don't have 10 minutes. I usually will just have them render it and I'll say, all right, you know what? We'll look at it again tomorrow. Or if this is at the beginning of class, we'll look at it again later. You'll see that it starts rendering it. And when it gets done, it will be fully rendered. You know, there'll be like a thumbnail here and they can click on it and pull it up. It's pretty fantastic, actually. The kids in my class, they absolutely love rendering things. And it's amazing what it does to their ideas when they can see it in a more realistic environment. I'm going to get out of this thing here now. I'm going to show you the finished result of where we're going to go first. So here's our 2x4. We're going to do a quick beam deflection test here, okay? I'm going to show you where we're headed, and then I'll show you how to take care of it. So this is a typical beam deflection. And it kind of tells us where the stressors are at and everything else. I'm showing you this up front of time because this is a thing when you do simulations, some of them can take considerable time. This beam deflection, when we do it in class, it takes about 3 to 4 minutes after we set all the parameters. So it's not too bad. But when we do drop testing, that can take, we'll just deal with it the next day, put it that way. So I'm going to start and I'm just going to create a 2x4. Just a brand new sketch here. Let's create that rectangle and I'll say, let's make this 1.5 by 3.5. So there's the profile for it. Then I'll extrude it and I'm going to make it 96 inches because that's 8 feet. I'll go ahead and hit the home button. The 2x4 is created. Now I could assign a material here if I wanted to, but when you get into simulation, you actually can pick them there too. So I'm just going to wait till I get there. I can go up here to design and say simulation. These are the different tests. There are quite a few that Fusion offers. When we're looking at right now is a static stress test. I don't know if we'll have time, but this dynamic event simulation, so they show you a football helmet. It's a drop test, is what it is. It's pretty cool stuff. We'll just stick with static for now. So I click static and I say create study. So just like anything else, we're going to kind of work from a left to right. There's a whole lot of stuff here that I'm not going to mess with for this test. For materials, you see, I already skipped the first one. I already had a new study. As soon as I came in here, it made one. Simplify, you could change up your design if you've got a lot of curves in it. For this, we're not going to get there, but materials, I am going to do. And right now, it's the same as model. Well, I never assigned one. So I'm going to click here and say, give me, gee, why is there an exclamation by area thing? And then if we go down even further, why is there exclamations by bamboo and birch and ash? And it's because with different trees, uh, there's not consistency, is there? I mean, you take a pine board has a lot of knots in it and everything else, so they can't guarantee consistency. The wood that you'll be able to use something like an MDF. Here's the MDF. I recommend doing something like an aluminum or something like that. It is kind of a bummer that you can't do wood because that's kind of what you would want to do is a 2x4. But the issue with that, like I said, you get it from a different pine tree, it gives you different results. So I'm going to choose aluminum and I'll choose OK. I've got a material. Now go to constraints. I'm only going to use a few. So I use material. I'm going to use constraints. I'm going to use loads. That's all I'm using for this one. Okay. So constraint wise, I've got to tell it where is it going to be fixed. For this, I'm going to make this a cantilever. So I'm just going to click and I'm going to put that on one end. It doesn't really matter which end, but you see that lock pops up, right? Right there. And I can press OK. So I've got this thing fixed. It's fixed at one end. Now the other end is where I'm going to put the load. So I've did materials, constraints, and now loads. And what I'll do is I'm going to click the opposite end. So I click here and you're like, hey, that's not going to get it, buddy. That's pushing against it. So I'll go here to direction type right in here. I'm going to click that button. Click it. And notice now I can actually rotate that force. Okay, and that's what I really want to do. And so my direction reference, I could have actually clicked it that way too. For my magnitude, the default is going to be set in newtons. So you can work with that. It's a good chance to have unit conversion talks. But I always have mine go to pounds of force because that forces them to change it. Because like I said, default's Newton. So for magnitude, I'm just going to say, you know what? Let's make it 500 pounds. And I'll press OK. I've done it. I've got this test set up. But I'm going to redo that part because I want you to focus on this part right here. See, I have a green check mark right now. That means I can run this test. But if I go back and just do one thing, like that force is gone, look at that. That thing's red. It's saying, hey, you're missing something. If it's orange, as you can see orange there, it says it can run, but it's probably not going to be a very good valid test, okay? So the reason this is red is because I am missing something, right? I need to put a load on there. So I'll click load again, and we'll just do that same part again. I'll click the end, choose direction type, rotate it up some. I can get to the, there we go. Move it on up, and we'll put the 500 pounds on again. 500. Press OK. From there, I got a green check mark, and I'll just click solve. And this is going to come up and talk to you about cloud credits as well, but you can just see, look at that, 0. And then you just say solve one study. Now it's going to make me save. I'll just say beam deflection, part 2. And you'll see, and in fact, it'll tell you, it keeps the progress total up here for you, like the simulation progress. It'll keep that going for you. But the nice thing is you can exit out of this, and this will run in the background. So you can tell the kids, go ahead and set up your simulation. We can do other things while we're waiting on this, because in a classroom, you don't want to be wasting 7 to 10 minutes here. Like I said, this one's usually 3 to 5 minutes though. So while that's working, I've got you one already rendered here, or already simulated. So when it comes up, here's the safety factor for it. Safety factor is not very good. Okay, it's actually very bad. It tells you actually right here, it says it's 1.4. Typically, you're trying to get at least 2. But instead of safety factor, let's look at stress. So there's the stress. And then I'll show the kids this, and I'll be like, so does this actually make sense? And they're like, well, why is it really low down here and really stressed up here? And I'll just tell them, be like, all right, so fill up a 5-gallon bucket of water and pick it up. Where is the stress at in your arm? Where's the anchor point? And they're like, oh, it's in your shoulder. I'm like, right. So your shoulder is where the lock is right now. So they're like, oh, then it does make sense. One I like to look at too is displacement. So the displacement here is 5.40 something. It actually deflected more than what it is tall, which is I'm pretty sure Newton would not be happy with us right now. There's a few others here too, but the displacement and stress and safety factor, those top 3 are the ones the kids get into the most. So this is our beam deflection. This is how it actually come up, and it'll tell us right now. Let's say actual safety factors 2.8, probably should be adjusted. You know, you probably fix it. But then we go to the deformation scale here. It says adjusted. You can actually click in that box and say actual. Shows you a more realistic picture of what would happen. And then we have good conversations about, all right, so if we've got a lot of deflection here, how could I make that better? So if I look at stress, how could I make that better? I actually had a kid a week or so ago when we did this, and he said, hey, it's right now it's only anchored to one point. It's a cantilever, so we could anchor it at both points, which is absolutely true. And then some of them will say, well, this is a 2x4. What if we did a 2x6? And then you'll have a kid say, well, what if we turned it flat? And then everybody in the class will look at the kid and be like, nuh-uh, bad idea. And then other kids will be like, well, we could double up here. We could triple up the thickness of these boards, which is often done, right? So it's good, healthy conversations that you're going to be able to have with the kids just by showing them those simulation tests.